Good day, everyone. I am here to discuss what is break-even analysis and linear programming is all about and how it is work. But first, let's define what it is all about. Let's start with break-even analysis. Break-even analysis is the point at which total cost and total revenue are equal, meaning there is no loss or gain for your small business. In other words, you've reached the level of production at which the cost of production equals the revenue for a product. Next is the break-even quantity equals fixed cost divided by sales price per unit minus variable cost per unit, where fixed costs are costs that do not change with varying outputs such as salary, rent, building, and machinery. Sales price per unit is the selling price or the unit selling price per unit, and the variable cost per unit is the variable cost incurred to create a unit. So, what are the steps in break-even analysis? Number one step is to determine variable unit cost. There are two types of costs. First is the total variable cost. Total variable costs are costs that changes proportionately with the changes in volume or capacity. The greater the capacity, the greater the total variable cost and vice versa. The second type is the fixed cost. For example, the cost of using gasoline in a vehicle is calculated by mileage, but the price of each liter of gasoline remains constant and it is not affected by the mileage. And the number two step is to determine fixed costs. Fixed costs can be more important than variable costs, and these costs have two characters. The first character is that fixed costs do not change or are not influenced by a particular period or activity. So the unit fixed cost is inversely proportional to the change in volume. If the volume is low, the unit fixed costs are high. On the contrary, at high volumes, the unit fixed costs are priced low. The number three step is to determine unit selling price. Determining unit selling price is certainly very important for your business growth and profit. When you set a new selling price, you can then find out how to calculate your sales profit. The way to calculate net profit per unit can be calculated after finding out the cost and the selling price per unit. Here are some of the important factors in determining selling price. Number one is the customers. A product is intended to attract the attention of customers and potential customers to buy the product. So you have to make sure that the selling price of your product is indeed a price that can easily be accepted by the customer. Do not set the price too high because it can be rejected by the customer, and do not set it low because it leads to losses. Number two is the competitors. It is also necessary to look at the selling price offered by competitors who have similar products. You must make sure that the selling price of your product can compete with the selling price of competing products. That means that you also need to pay attention to your level of profit. If the predetermined level of profit causes the price to be too expensive, then it may be a good idea to apply the method of calculating product profit and loss by lowering the potential profit to get a price that is not too far away from the price offered by the competitors. And lastly, the number three is the cost. This is the most important factor in determining the selling price of the product. Do not set the selling price lower than the cost because you will end up with a loss. And the number two steps is the number four rather step is determine sales volume and unit price. The break-even points will change as the sales volume and the unit price changes. Calculation of break-even points are as follows. BEP such as break-even point, FC as fixed cost, P unit price, and VC as variable cost. From this formula, we can observe that the break-even point is equal to the total fixed cost divided by the difference between the unit price and the variable cost. You also have to note that in this formula, fixed costs are expressed as the total of all overhead costs for the company. while the price and variable costs are expressed as cost per unit or the amount for each unit of product that is sold. Question number 1 in break-even analysis. Number 1. Roha Products sell camping equipment. One of the company's product, a camp lantern, sells for 900 per unit. Variable expenses are 630 pesos per lantern and fixed expenses associated with lantern total of 1,350,000 per month. At present, the company is selling 8,000 lanterns per month. Compute the company's break-even point in number of lanterns and in total sales pesos. So the solution is BEP, such as break-even point in units, BEP, P, break-even point in peso, TFC, total fixed cost, CMU, contribution margin per unit, and VC, such as variable cost. So the BEP in unit is equal to total fixed cost divided by contribution margin per unit. TFC is equal to 1,350,000 over 270, which is the contribution margin per unit. And the break-even points in units is equal to 5,000 units. So the CMU, such as contribution margin in unit, is equal to sales per unit equals variable expenses. Sales per unit is equal to 900 and the variable expenses is equal to 630. So the contribution margin per unit is equal to 270. While the break-even point in peso is equal to, the formula is total fixed cost is divided by 1 minus variable costs over divided by sale, or total fixed cost is divided by contribution margin in percentage. So the sales is 900 times 8,000 is equal to 7 million to 200,000, and the variable cost is 630 times 8,000 is equal to 5,040,000. So 1,350,000 is equal. In other steps, 1,350,000 divided by 1 minus 5,440,000 divided by 7,000, 7,200,000 is equal to 1,350,000 over 0.3. So the BEP, or the break-even points in peso is equal to 4,500,000. While the contribution format income statement, or the break-even point in table, is lantern 5,000 units is equal to 4,500,000 and in unit is 900. Variable cost in is 3,150,000 and in unit is 630. In contribution margin, 1,350,000 or in unit 270. Fixed cost, 1,350,000 and the net income is total to 0. Now, let's talk about naman how linear programming works and what it is all about. Linear programming is mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. The technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and to a lesser extent in the social and physical sciences. The solution of a linear programming problem reduces to finding the optimum value, such as the largest or smallest, depending on the problem of the linear expression objective fun- that called objective function. So, how is it works? But first, let's discuss what are the steps in linear programming. Number one is understand the problem. The goal of a linear programming problem is to find a way to get the most or least of some quantity, often profit or expenses. This quantity is called your objective. The answer should depend on how much of some decision variables you choose. Your options for how much will be limited by constraints stated in the problem. Number two is to describe the problem. What are you trying to optimize? Are you trying to minimize costs, maximize production quantities? You may have constraint like you can spend more than $1,000 or you must ship at least 50 tons of product C. These are limits but don't necessarily reflect your employer's top priorities. Don't mistake don't mistake this for suggestion that you minimize costs for maximize production. Number three is to define the decision variables. The answer to a linear programming problem is always how much of some things. What are those things? Choose variables to represent how much of each of those things. For example, letter L, num- number of leadership training programs offered, and or letter P such as number of problem solving programs offered. Number 4 is write the objective function. Use the variables you choose to write down an algebraic expression that describes the amount you're trying to minimize. Do not use an equal sign or do not use less than or greater than signs. Number 5 is describe the constraints. What are the limits on how much your decision variables can be? Look for words like at least, no more than, two-thirds of, or we must fill orders for, or etc. Number 6 is write the constraints in terms of the decision variables. For each constraint, such as at least $500 or no more than 29, write an inequality using the decision variable. Number 7 is add a negativity constraints. Do not forget to include the negativity constraints like P is less than or equal to 0. These are worth a quick 2 points on the quiz. And lastly, number 8, write it up pretty. Maximize it. Number 1 in linear programming. At a university, Professor Simon wishes to employ two people, John and Mary, to grade papers for his classes. John is a graduate student and can grade 20 papers per hour. John earns $15 per hour for grading papers. Mary is a doctoral associate and can grade 30 papers per hour and can earn $25 for grading papers. Each must be employed at least 1 hour a week to justify their employment. If Professor Simons has at least 110 papers to be graded each week, how many hours per week should he employ each person to minimize costs? Solution in the problem. Step 1 is to define the decision variable x, number of hours per week John is employed, and y, number of hours per week Mary is employed. Step 2, define the objective function. The objective function is c is equal to 15x plus 25y. Step 3 is to define the constraint. The fact that each must work at least 1 hour each week result in the following two constraints. X is greater than or equal to y to 1 or y is greater than or equal to 1. Since John can grade 20 papers per hour and 30 papers for Mary, and there are at least 110 papers to be graded per week, we get 20x plus 30y or greater than or equal to 110. The fact that x and y are non-negative, we get x is greater than or less than to 0 and y is greater than or equal to 0. The problem has been formulated as follows. Minimize c is equal to 15x plus 25y, subject to x is greater than or equal to 1, y is greater than or equal to 1. 20x plus 30y is greater than or equal to 110, and x is greater than or equal to 0, y is greater than or equal to 0. By graphing the constraint, we were able to identify two critical points, 1 and 3 and 4 and 1. We will substitute this to our objective function in order to get the lowest cost possible. So, 15x plus 25y. 15 times 1 plus 25 times 3 is equal to 90. 15 times 4 plus 25 times 1 is equal to 85. So, 4.4 and 1 point gives the least cost, which is $85. Therefore, we will conclude that in order to minimize costs, Professor Simon should employ John for 4 hours a week and Mary for 1 hour a week at a cost of $85 per week. So, that's the end of our discussion about break-even and linear programming. Hope you learned something. Again, this is Renz Racine from BSA 401. Thank you so much and I hope to see you soon. Bye!